Hello and welcome to the talk Exploring Code Bases with RedisGraph. First, we'll discuss how to model source code as graph. We'll introduce a tool which creates a RedisGraph model from Python code. The major part will be a demo. We'll use the Cypher query language and the RedisInsight visualization tool to explore the awesome Docker Compost code base. My name is Reka. I've been working with several technologies in the last 2 years, mainly with Python. The examples in this talk will be in Python. The concepts apply for other languages as well. This story started on a particularly cold winter weekend when I bumped into Carlos Justiniano's fantastic talk, Creating a Model of Human Physiology with RedisGraph. If you want to see some amazing biotech models, check out this talk. For me, the examples like the one on the left were even more fascinating. Apparently, you can detect surprising relationships even in a small dataset. It immediately made me brainstorm other usage possibilities for graphs, and I quickly came to the topic of code bases. During the demo, we'll use graph queries in 2 different kinds of investigations. We'll see some structures and patterns. We'll answer questions along the lines, is there such a thing? And especially, is there such a relationship? Is there a test function calling another test function? Where are the dependencies between the different packages? In order to answer those questions, we'll model our source code as graph. For that, we are introducing the tool TycoGraph. TycoGraph takes Python code as input and creates a RedisGraph model with nodes and edges from it. The diagram shows the steps how TycoGraph achieves this. First, it uses the AST module of the Python standard library to create abstract syntax tree objects. Then AST to Pyco module creates intermediary objects from the abstract syntax tree. These represent both some elements of the syntax and the relationships between them. Finally, the Pyco to RedisGraph module converts those intermediary objects into RedisGraph nodes and edges. This step is relatively straightforward thanks to the RedisGraph Py library provided by Redis Labs. The majority of the logic is happening in the AST to Pyco module and in the intermediary objects. After this introduction, let's see a demo. And for that, the first thing we need is a Redis instance with the RedisGraph module. And the easiest way to achieve this is, of course, with Docker. So I have just started a Redis mod container, which contains all the Redis modules. And we also need a RedisInsight container. Now we have a Redis database, which is empty. In the next step, we'll load some data into it and create 2 graphs with the TycoGraph load command. We provide 2 options, the project dir, pointing to a directory on my local system, and the test types, which tells TycoGraph that it should differentiate between the different types of tests. If we execute the command without any options, it searches for Python files in the current directory. So now we have 2 keys in our Redis database, and behind both keys there is a graph model. So it's time to execute some queries against it. It's almost obligatory to start a demo about Cypher with the return everything query. So let's see what it shows us for a relatively small code base like TycoGraph. Well, even for that code base, there are quite a lot of nodes and edges. since version 1.10, RedisInsight has this convention that the more edges a node had, the bigger it is represented. Of course, it is just a proxy, but it still gives you a kind of feeling about a node's relative importance. And you can perhaps detect some of the elements of the diagram we have just seen. For example, this is the AST to Pico module, and these orange nodes are the intermediary objects. Of course, you can execute the very same query against a much bigger graph as well. So let's see the same for Docker Compose. And the result is visually somewhat overwhelming. Sometimes we can see is an amazing test suite. So for example, we have 40 test modules for the 39 modules. And the biggest nodes tend to be somehow related to tests. So for this reason, in the next query, we are going to exclude those test objects and take a look only at the production code. Here I would like to mention that in TycoGraph, we distinguish between production and test code in two different ways. One is this test object property, and the other one is that there are separate labels for functions and test functions, classes and test classes. So now we have a still quite big picture, and we can see some of the major elements of the production code. For example, this top-level command seems to have a quite appropriate name because according to this overview, it's top-level indeed. After these giant pictures, let's see something different, a query which returns exactly one node. For that, it's practical to have a property which is unique among all nodes. In case of TycoGraph, this is the full name property. And in the next examples, we'll examine some code you probably rely on a daily basis. The up function, which is the function behind the Docker Compose up command. So if we execute this function, this query, the result isn't so spectacular, just one circle. But if we double click on it, you immediately see all its edges. And we will continue exactly with those edges with the calls relationships. So again, we return the node representing this up function and all the nodes which it's calling. Sorry, this is one. So here we can see that there are quite a lot of calls to this top-level command. This is the class which contains the app function. And if we want to get a somewhat clearer picture and exclude this, we can add the where condition. And here we see it's very handy that the edges can also have properties. So we can say that we exclude all the calls where the reference name is self. Okay. Now we see that app is calling 14 different functions and this user error class. And if we want to learn more about those functions, we can examine these nodes and see all the properties at the bottom. Or another way is to improve our query one step further and also ask where those modules are. So which object does contain those functions which are called by app. And if we clean up this picture a little bit, then we can see that the vast majority of these functions app is relying on are located in the main module, and this is exactly the module where app itself or its class top level command is located. So it implies a nice cohesive structure. Some examples have probably given you some ideas what kind of queries you can execute against your source code graph. So now it's time to answer some specific questions. Which is the most often called function in this code base? And for that, we will use an aggregate, the count, and we'll order by this count. Now we aren't really interested in this visual result, instead in this table style. And this is the time where I want to mention that we can execute these very same queries in the CLI also. And we'll get a result in this structure. But for this demo, we'll stick to the RedisInsight tool. And yes, we have a clear winner, this load from the config module. So as the next step, we would like to figure out who are those functions calling load. And now we see something perhaps interesting, that yes, we do have 162 calls indeed, but the majority of them is actually coming from test functions, 5 from test helpers, and there are only these 2 functions here which are calling load from the production code itself. Speaking about tests, one frequent question about Python projects is which style or styles of testing it is using. There are 2 basic styles. The unit test approach, in the unit test approach, the test functions live in the test classes, which inherit from unit test.test case. In the PyTest approach, the test functions live directly in test modules, and there are no test classes at all. So in order to figure this out, we are using again a function, a query which contains an edge, and on the right side we specify the test function label. But on the left side we don't provide a label. So we are interested in all types of objects which contain a test function. And again, the picture isn't that interesting, but here we see that we have found 83 test classes and 5 modules which directly contain a test function. So we can see that, as in several other projects in Docker Compost, these 2 approaches also coexist, but the class-based one seems to be much more popular here. Speaking about tests, one frequent question is there any dependency between the test functions? And there are many different types of dependencies. One of them is a test function calling another function. And let's see whether we detect such cases. And yes, it happens exactly once. Detecting dependencies is generally a good topic for graph queries. So in this last section, we are trying to cover the dependencies between the different packages. And in order to do that, we are again examining function calls. But this time, we don't really care about the functions themselves, but more about the packages which contain them. So we will use again this count aggregate function and group the results by caller package and called package. And as we have probably expected, we see that most of the function calls take place within a package. So from Compost to Compost, Compost config to Compost config. And If we are specifically interested in calls between different packages, we can add the where condition, where we see that caller package and called package must be different. Again, this unique property with the full name is handy. And here we see that there are just very few such calls among the packages. So it seems that the package boundaries are quite well defined. One surprising thing is that there are two calls to a function in Compost CLI from somewhere else, so from the Compost package. Let's figure out what is that. And again, we have a very similar query as the previous one, but this time we don't have a count. Instead, we explicitly want to see the caller package and the caller function also. And indeed, it's one util function, this binary str to Unicode, which has two calls from the Compost package as well. So these examples have probably given you some ideas how you can discover your code base with a graph structure, and probably also some ideas of the many possible improvements. They go in two basic directions. We can model further more detailed elements of our syntax tree. So external dependencies, if branches, error handling blocks, just to mention a few examples. The other big possibility is to integrate this tool with other tools we frequently use. Git, continuous integration pipelines, and test coverage are among the first candidates. After seeing several examples, let's summarize some takeaways. First of all, distinguish between production and test code. Both are important, but they are different. You have probably different rules and code conventions for them, which is leading us to the second point. Be aware of your architecture and code conventions. These should guide your queries and also how you interpret those results. Don't aim for a perfect model. The goal is to improve your understanding about the code base and not to capture every single detail. And exactly with that, the most important point is probably the last one, keeping in mind the limitations of this tool. So I like it, for example, very much if a code formatter takes decisions for me and immediately fixes all the errors it finds. But this tool is something completely different. Its job is to improve your understanding, and it might point out some possible sources of errors, and it might even be a good idea to define some more warnings based on it. But it definitely shouldn't trigger any kind of automatic code changes and cleanup. Now it's time to say a huge thank you to everyone who has contributed to TycoGraph or to this talk. I especially would like to highlight 3 people. Oshaya has encouraged and improved TycoGraph from its very first very awkward prototype. She has always provided excellent feedback and pushed both TycoGraph and the talk into better directions. Boro has been a huge help both with her encouragement and her practical tips. How to create a plan from a huge chaos and how to get a reasonable version before deadline. Last but not least, Ajit, the official reviewer of this talk. His vast knowledge about conferences and communities has been a huge help in many ways, from getting a logo to structuring the talk. His contribution converted a funny toy into a presentable tool. You can learn more about TycoGraph at tykograph.com. You can find there all the examples from this talk and some further resources as well. The source code is available on GitHub. Contributions, pull requests, questions are very welcome. If you want to learn more about RedisGraph, the first place to go is the excellent documentation. For those who are motivated to dive deeper, the source code is also available on GitHub. RedisInsight isn't open source. I still encourage you to take a look at it. It provides excellent visualization, not only for RedisGraph, but also for Redis and the other modules. My next recommendation is to visit Ajit's blog Collabnix, both because of the awesome resources on a high variety of DevOps topics, and because of the active community and many different events. Thanks a lot for your attention. I hope that you have learned something interesting both about graphs and code bases.